Here are the answers to Unit 7 free response question 1. This is the first time we've seen what's called an investigative task. These are questions that tend to go into a little bit more depth and might be slightly more challenging and have lots of different correct answers. For the 2020 AP exam, there will not be an investigative task, but a lot of the topics within this question are certainly something that could appear on the test. So again, as you prep for the AP test, watch this video, pause, attempt the question again, and then watch the answer. So the first part says, again, remind you to show your work, and that's kind of important. Bank categorizes customers into one of three groups, and here are the summary statistics for the three groups. And then the bank manager will investigate whether there's a significant difference in the mean number of bank visits for the groups. Multiple two-sampled t-tests will be conducted, each at a significance level of 0.05. How many t-tests will need to be conducted for the manager's investigation? List the pairs of groups for each test. So the correct answer to this question involves having three pairs of groups. A is paired with B, A is paired with C, and then B is paired with C. It is incorrect to change the order and include those. So your answer should have just three groups, not six. Essentially correct is showing the three pairings. Partially correct is saying that there are three pairings without actually showing them. And incorrect is anything else. If you listed all six, then your response was considered partially correct. Part B was broken down into a couple smaller steps. The first part is, if the probability of something being significant is 0.05, which is the type 1 error rate for this problem, what is the probability of not significant? This is a very short, quick answer. If significant is 5%, then not significant is the complement, which is 0.95. So the next part asks you to consider multiple t-tests. They're going to start by giving you two different t-tests, and the outcomes are arranged in this kind of a tree diagram. The first test can either be not significant or significant, and then the second test after the first is performed could also have the two different outcomes. You're asked to find the family error rate, which is the significant result for at least one of the t-tests under the assumption that the null hypothesis is true. So to calculate the probability of obtaining a significant result for at least one of the t-tests conducted, if you look at the tree diagram, at least one S appearing happens in three branches. Significant paired with significant, or significant paired with not significant has at least one significant, and then not significant paired with significant again has at least one significant. Since you could do three different calculations, a more efficient way could be to say, let's take the complement of not significant and not significant. So that's what's happening right here. The complement of not significant and not significant is 1 minus 0.9025, and the 0.9025 comes from not significant and not significant multiplied together. Not significant is 0.95 squared, which is 0.9025. So the correct answer is 0.0975. In an investigative task, there's often more than one way of doing things. You could add together the three branches, and that's the calculation that's happening in this area here. It's just not significant times significant occurring two different ways, and then significant times significant occurring the other way. Adding those three together gives you 0.0975. But again, taking the complement of the red branch is more efficient. You were essentially correct if you got that value and showed the work on how to calculate the family error rate. Part C asks you to calculate the family error rate for the number of t-tests identified in Part A. And if you got Part A correct, that means you're going to calculate the family error rate for three significant tests. So extending the idea from Part B a little bit further, this time with three significant tests, you're going to have three different branches on your tree diagram. First test, second test, and third test. And again, you could calculate the probability of at least one significant test by traveling down all the branches that have at least one S, or the more efficient way is to travel down the three branches that are not significant and take the complement of those. They changed the tree diagram, and this time the complements are at the bottom instead of the top, but the calculation is the same. You're going to find the probability of not significant, and not significant, which is 0.95 to the third power. When you subtract that from 1, you get a family error rate of 0.142625. So So again, you got full credit and it was labeled essentially correct if you had the correct value and you had work shown. There's a couple different ways of showing the correct value. You could do just a straight probability calculation, or you could fill out a tree diagram. And then finally, the last part says the manager wants the family error rate to be close to 0.05. If you remember the answer to the previous question, the error rate was 0.14, which is very high. Suggest a single significance level alpha that can be used for all the individual t-tests will bring the family error rate to close to 0.05, show work and support. So there were two different ways of doing this, and I like the second approach better. What you want to aim for is a 0.05 at the end instead of the 0.14 that we got when we did the 3 branches. If you're aiming for a 0.05, what alpha should you start with? Well, if you just take the calculation that we did, the complement of the 3 branches, and work backwards, you can solve this probability of significance as your alpha. If you start with a 0.01695 or 0.017, at the end of the family error rate, you'll be close to 0.05. So that's one way of doing it. Another way is just to guess. If you took 0.05 for alpha and then divided it by 3, because there are 3 tests, you get this number, and then when you plug it in and test it, you wind up being very close to 0.95, which is what you were looking for, because a 0.95 produces an error rate or a family error rate of 0.05. Either one of those was an acceptable method. Here's the grading. There were 4 parts. Each was labeled either essentially correct, partially correct, or incorrect. Point values are here. Sum them all up, and if you wound up with a half score, it was rounded up or truncated down based on the support you provided and a holistic grading approach.